Good morning. I am P. Vijayalakshmi, Assistant Professor in Department of Mechanical Engineering, Thandai Periyar Government Institute of Technology, Vellore. Today we are going to discuss a lecture on gearbox. So what are the functions of a gearbox? So the main function of a gearbox is to provide for the variation of torque. There is always a variation of torque based upon the tractive effort that is needed. So when starting, we need the torque is more, while cruising, the torque is less. So to accommodate for this variation of torque, we need a mechanism, and that is provided by gearbox. In addition to giving variation in torque, it also provides variation in speeds. Naturally, gearboxes are capable of providing 3 or 4 speed ratios. Nowadays, we have 5 speed ratios too. And you also have a neutral gear which helps to disconnect the transmission line even when the clutch is in the engaged position, where we wait in the signals when we wait in the signals. So in such case, we can put the gearbox to neutral. So the clutch will be in the engaged position, but the power will not be given to the transmission line. So all these functions are being carried out by the gearbox. So next we'll see what are the various types of gearboxes. So you have a manual gearbox where all the operation or shifting the lever, gears, etc. is done manually. So under manual we have 4 types. One is sliding mesh gearbox, constant mesh gearbox, synchro mesh gearbox and epicyclic gearbox. Then we have semi-automatic where we use flywheel, fluid flywheel and torque converter. And the other one is fully automatic where we use hydromatic transmissions. Now we'll discuss about sliding mesh gearbox. So as the name suggests, we have gears which slide on a splined shaft. So since the gears are sliding on a splined shaft, it is called as sliding mesh gearbox. The sliding mesh gearbox consists of the main shaft and the lay shaft. So the main shaft is the shaft which is splined and carries gears which can be moved along the splined shaft. And you can see in the lay shaft there are a number of gears, but these gears are not capable of moving along the lay shaft. Generally, they are cast integral as a single piece. So the number of gears on the main shaft depends upon the number of ratios that it is being designed. So now we have 2 gears, so therefore we can have 3 gear ratios. If there are 3 gears, then you can have 4 gear ratios. So now this shaft is called as the clutch shaft, which is coming from the clutch, and this gear is called as the clutch gear. So the clutch gear is going to give the drive to the gearbox. So you can see the gear shifting levers which help in selecting the gears and engaging them. So based upon the speed requirement, the shifting lever selects the gears and it engages with the spline. So when we want the speed, generally the speed is very low and the torque requirement is high. So for the first speed, we generally take a larger gear on the main shaft and a smaller gear in the lay shaft. Now we can see how the power flows from the main shaft to the lay shaft and back again to the main shaft. So you can see the clutch gear. So the clutch gear is now, so the clutch gear, this is the main shaft. So even though it may seem that these two are connected, these two are separate entities. So clutch gear, main shaft, gears, sliding gears, lay shaft, and all these are fixed gears. So for the first speed, the clutch gear is getting engaged with the counter shaft. So if this is rotating in the clockwise direction and this will rotate in the anti-clockwise direction. Since I want a smaller speed, the lever selects the larger gear and engages it with the smaller gear in the place shaft. So now what happens? This shaft rotates. As a result, this shaft also rotates. Since this gear has smaller number of teeth and this has larger number of teeth, this will rotate at a faster rate, whereas this will rotate at a slower rate, and thereby the torque is also multiplied. So for the first gear, the torque is high and speed is low. So this is rotating in anti-clockwise, this clockwise, again this is getting meshed, and again this comes to the clockwise direction, and from the main shaft it goes to the universal joint and the rest of the transmission line. Now we can see how the second gear works. So in the first gear we saw that the larger gear was engaged with the smallest gear in the lay shaft. Now for the second gear, the lever is selecting the second largest gear. And in the counter shaft you can see that it is selecting the gear which is slightly larger than the gear which was engaged in the first shaft. So here again you get a reduction in the speed, but it will be higher than what is the speed for the first gear. And then you can see for the third or the top speed. So here they directly engage the clutch gear with the main shaft. So you have a dog clutch here. The dog clutch engages the clutch gear with the main shaft. So there is no gear reduction. It is the top speed or the third speed. And for neutral, none of the gears in the main shaft are engaged with the gears in the counter shaft. So the drive from the clutch gear goes to the counter shaft, and from the counter shaft it doesn't go to the main shaft. So it just keeps on rotating. So the transmission is not going back to the main shaft. So this is how the neutral gear works. And then there is one more speed called as the reverse speeds. For the reverse gear, an idler gear is being made use of. This idler gear is mounted on a shaft which is pinned to the casing of the gearbox. So this idler gear is capable of rotating in the shaft. This idler gear does not play any role in reduction of speed as well as in varying the torque. Idler gear is mainly used for the purpose of changing the direction of rotation. So when the idler reverse gear is engaged, the transmission comes from the clutch gear to the counter shaft, and the smallest gear in the counter shaft. Usually reverse speeds are at very low speeds. Therefore, you make use of the pair of gears which we use for the first gears. So it comes from the clutch gear to the counter shaft. The smallest gear in the counter shaft engages with the idler gear. The idler gear engages with the largest gear in the main shaft, and from the main shaft the drive goes to the transmission line. So now we can see the direction of rotation. So if this is rotating in the clockwise direction, automatically the counter shaft due to external mesh will be rotating in the anti-clockwise direction. So if this is rotating in the anti-clockwise direction, then the idler gear will be rotating in the clockwise direction. And again, if this rotating in the clockwise direction, then the main shaft will be rotating in the anti-clockwise direction. So the vehicle will move in the reverse. So this is how the reverse gear works. So now we have discussed the sliding mesh gearbox. So sliding mesh gearbox consists of main shaft, counter shaft, and it mainly uses spur gears. So this gearbox is a 3-speed gearbox. So we have seen how the 3 speeds are obtained. So for the first speed, we engage the smallest of the counter shaft gears with the largest of the main shaft. For the second speed, the second largest and the second smallest. And for the third gear, we directly engaged the clutch with the main shaft, clutch gear with the main shaft by the use of the dog clutch. And for the reverse gear, we made use of the idler gear, which is mounted on a pin attached to the casing. So the advantages of this gear box is that spur gears are easy to manufacture. So it is very easy to manufacture and assemble. And the main disadvantage is in spur gears we have contact stresses, so the life of gears is very less, and there is always a clashing sound when the gears are being engaged, and especially at higher speeds the mating gears clash and that will damage the gears, resulting in backlash. So to overcome this, they have designed two new gearboxes. One is called as the constant mesh gearbox. And to overcome the drawback that arises in the constant mesh gearbox, a synchromesh unit was later designed. We will discuss about these two in the next lecture. Thank you.